Do you want me to do it on my computer?
No, I'll just do this for now. Thank you, though.
So, do you say since x not goes to infinity, there's already a...
Xn goes to x.
Right.
There's already an epsilon, right? And then for x, there's already an epsilon.
So for every epsilon, there exists an n naught, right? So we kind of need an epsilon.
Epsilon.
We're not leaving it arbitrary. We're going to actually pick one.
Epsilon divided by beta.
Just make it fine.
Okay, can you just use epsilon, and then for the z, can you use beta over epsilon?
Can we just...
And then when you multiply them together, you get beta.
Yeah, you want to get something that multiplies to give you beta, don't you? So you've got so here's 0. X is over here somewhere, right? And we know that this xn sequence, I mean, it could be all over the place for a while. Eventually, it's coming into x, right? So you want to pick an epsilon, a specific epsilon here. And then you also want to kind of pick a specific beta to go with the Zn sequence, right? Just not clear. I mean, could I just let epsilon equal 1? Or would there be a different choice?
X over 2, because you don't want 1 because
Right, that's a good idea. Let's keep 0 out of this. We don't want these terms to go negative, because if they do, then gosh, multiply. You might have Zn going towards negative infinity, but if you've got terms of the x sequence that are still negative, then the product would be blowing up to plus infinity, not going to minus infinity. So I like this idea of choosing epsilon. For this part, I'm going to choose x over 2 as my epsilon, which is going to make an interval like that, right? We're going to make this kind of an interval at this point. You guys okay with that? So there exists, so by definition of xn converging to x, there exists an n1. This is not our final n naught yet. There exists an n1 such that if n is greater than or equal to n1, that implies that the absolute value of xn minus x is less than x over 2. And that really just means that xn, is between x over 2 and 3x over 2, right? That's basically what this picture shows. You guys okay with that? Okay, so xn is ending up in this interval. We're going to be multiplying that by zn. So we're going to have to choose our beta properly now. Okay, so there's going to be a beta such that by definition of Zn converging to minus infinity, there exists an n2 in the natural numbers such that if n is greater than or equal to n2, Zn is less than, we can put whatever we want in that box. 2 beta over 3x is your proposal? Is that your proposal? 2 beta over 3x. Let's try it. Okay, let's try it. So then what do we do to choose our n naught?
the max of
Take the max of the n1 and the n2. n1, comma, n2. We take the max of those. Okay. And now we're going to assume that n is greater than or equal to n naught, and we're going to check it, right? So assume n is greater than or equal to n naught. We then need to look at xn times zn, right? That's what we have to do. xn times zn. So the idea here now is that, xn is less than 3x over 2, and zn is less than 2 beta over 3x So that just comes out to beta, right? Let me just see if this is what I came up with.
Depends on what your initial.
Okay, this actually, hold on a second. This is not what I have in my solutions. I need to stop and think for a second here. I have a different thing in my box. So I just want to make sure that I understand why I do. Actually, so X and Z N. Actually, this actually might be okay anyway. I think this actually also works. It's just not the one I chose. I happen to choose X over 2. Sorry, I didn't put the 3 on the bottom here.
Do we have to pick the biggest one? Well,
The max
right,
of the N1 and N2, definitely.
between X and?
Oh, yeah, which one do you pick?
Right.
Yeah, that's the whole issue I'm trying to
We
address.
have to pick the one that is the bigger, that is the bigger one, right? Because
Less than X, and it's less than that.
You just need to make sure that the product of these comes out less than beta, right? So, the thing you need to remember here, though, is that beta is negative. So this second piece is a negative number. So when you multiply that negative number by this positive number, right, you're ending up with a negative number. So do you want a bigger negative number or a smaller negative number? That's where the issue lies. And as it turns out, I don't think it matters, because this this argument.
You get 3 beta, which is less than beta.
See, this part is less than this part, right? And then you're just multiplying them by 2 positive numbers, right? And this one being smaller than this one. So,
That makes sense, actually.
I don't know if I'm quite happy with this yet. It's all about the signs of these. Hold on a second. So, okay, so Zn is less than 2 beta over 3x, but both of these things are negative, right? So for example, this might be negative 10 and this might be negative 7 or something, right? Now you're multiplying xn by, you're putting an xn here, which is a smaller number. So what if xn was 2 and 3x plus 2 over 2 was 3 or something? So then you're multiplying this one by 2 and you're multiplying this one by 3, and it's not working. It's not working. So, okay, so look guys, you have a negative number here that's more negative than this number. So you need to actually take this more negative number and multiply it by something that is larger, right? To keep this a positive larger number. So you actually need to, the larger number that you would be using would be the x over 2. So xn is larger than x over 2. So we do need to, you do need to use this. This is tricky. If you made this mistake on the test, it would be like a 10-point problem. I'd probably give you either 8 or 9 points out of it, just for what you have here, because it's the right idea. It's a little bit of a tricky sign thing, that you want to make sure that what this Zn is being multiplied by is a larger positive number than what this one is being multiplied by. That's the point. So this is how it works. It's basically, you get this condition and it's just a matter of which of the two do you plug in. And it turns out you should use the x over 2.
That 3 would be gone too.
So this 3 should be gone too. Yes. Okay. Right, so this is a little tricky. But if you have one negative number less than another negative number and you want to preserve that, you better multiply, and you're going to multiply by positive things, you better put the bigger positive thing here and the smaller positive thing here. So this is the bigger positive thing compared to this smaller positive thing. That's the idea. It's kind of, it's almost like just number sense. is what that's dealing. I mean, I have another one. I have another part here that says prove that if xn converges to x, and if zn converges to plus infinity, then xn plus zn converges to plus infinity. That's a much easier problem, right? Everything's positive. It's very, very straightforward to get that one to work out. Okay, so let me see what else. Okay, let's do another one here. You guys want to keep going? Is it 6:30 yet though?
6:45.
It's 6:45. Okay, I am going to stop by 7. As exciting as this is, I am going to stop very soon. Okay, in fact, I'm going to go grab my phone after I put up this question and just check my phone real fast. So, here's what I want us to do. Compute the limit. This is which number? 12? Okay, compute the limit as x approaches 1 of f of x, where f of x is equal to, it's a piecewise function, x squared minus 2x plus 4 if x is less than 1, 5 if x is equal to 1, and 8 minus 5x if x is greater than 1. So I want you guys to think about that for a moment. I'm going to be right back. Actually, do more than think about it. Start trying to solve it. I'll be right back.
Like, you plug it into like the top and the bottom one, and you play it as 3. So you can call it as 3. And then, that's what I got.
I'm running out of keys. I still want to do what you're doing. It's easier.
That's what we do.
Well, can we just figure out what the limit is normally, and then we prove it? And I think that's what you're going to do. Yeah.
Then you plug it in and then.
Yeah. So it will be.
Okay. Looks like I'm doing fine so far. Let's try and get. So does anybody have any ideas on this one? Okay, I'm gonna write down a proposed proof. Okay, you guys tell me if you like it. Okay. So, for x less than 1, we have limit as x goes to 1 of x squared minus 2x plus 4, and then by the limit theorems, this gives me 1 squared minus 2 times 1 plus 4, which is 3. Okay, and then for x greater than 1, we have limit as x approaches 1 of 8 minus 5x, which again by the limit theorems is equal to 8 minus 5 times 1 equals 3. Thus, limit as x approaches 1 of f of x is equal to 3. Do you like that proof?
Well, from there we can just make the claim that we can have an assumption that the limit is 3, but then we have to prove it.
Well, I'm asking, is this proof okay?
No.
What's wrong with the proof?
How about the x equal 1?
Do we care when x equals 1? No, when you're doing limits as x approaches 1, you don't care about x equals 1, that's why I never mentioned it.
Could be a hole
Yeah, it could be a hole in the graph, so I didn't even mention that. Yeah, in fact, what is this graph going to be? It's going to be some sort of a parabola that then has a I guess, a circle there and then a line like that maybe, and then there's a point at x equals 1, which is up here. So this is like 3, and then this is like 5 or something. Whatever. So I mean, I think you guys agree with me. The limit will equal 3. It does exist, and it equals 3. The question is this a valid proof of it? You know, if the function was just this for all x's, then you could just use the limit theorems and say the answer is 3. Or if it was just this thing here for all x's, then yeah, you could just say the value of the limit is 3. The problem with this, with what you've done here, is you've tried to take one problem and split it into 2 problems. And the 2 problems combined are not equivalent to the one problem. Really, you're calculating here a left-hand limit. We didn't really talk about that this semester, but this is like a left-handed limit, and then this is a right-handed limit. So you're calculating these one-sided limits and then trying to say, oh, well, therefore the whole overall limit is that value. We have not introduced that as a valid approach whatsoever. In fact, by creating a piecewise defined function, I am forcing you to not use the limit theorems. If I want to create a problem where you can't just do the limit theorems, this is how I'm going to be able to do that. So what am I going to have to do? I'm going to have to use the definition. I'm going to have to use the epsilon delta definition. Everybody agree why you can't do this here, right? Because you're not looking, right? You're supposed to be taking a neighborhood of 1, right? There's a delta here, and you're looking at all x's in that neighborhood. Well, I'm trying to do it half at a time, and not doing it all at once, and that's where the problem is. Okay, so we're going to have to go back, and we're going to try to do this all at once by using a sort of more standard argument. Yeah, Eric?
So are you saying right and left-hand limits don't work here, or just that
We
it's
didn't-
not valid?
We haven't studied them, so there is a way of characterizing a two-sided limit, which is to say that both one-sided limits agree. But we haven't
Right.
done that. Yeah, we haven't actually gone into that direction. So I wouldn't want us to take advantage of that. Okay. So we should use the definition. Okay. So let epsilon greater than 0 be given, right? And then what we have to do is do some scratch work to write out how to come up with the delta. So the scratch work is going to consist of looking at f of x minus L, the L being 3, less than epsilon here. Okay? Now, we can do the scratch work backwards in sort of 2 cases. So, for x greater than 1, we have, let's just do that one first because it's easier, 8 minus 5x minus 3 less than epsilon. Okay, which is just, 8 minus 3 is 5. I can take the 5 out. I guess 1 minus x less than epsilon. And so this is if and only if the absolute value of x minus 1 is less than epsilon over 5. So, in other words, if you only were looking at x is greater than 1, you could use that delta. Okay, but again, we don't want to treat them as two. And I've seen people do that. They'll say, "Oh, let delta equal that," and then they do their whole proof, and they say, "Oh, therefore we're done in this case. We're done if x is greater than 1." Well, you aren't done if x is greater than 1 or if x is less than 1. You're only done once you have a single delta that works for everything, right? So the x less than 1 case is going to be x squared minus 2x plus 4 minus 3 less than epsilon. Now for this one, this is just x squared minus 2x plus 1, which actually becomes x minus 1 squared, actually, right? Less than, which we don't even need the absolute value bars for. X minus 1 squared less than epsilon. Okay, so then what does that tell me? So I'm going to ask you, so then what is, then that tells you that the absolute value of x minus 1 is less than the square root of epsilon. Very good, right, okay. So now we can do this proof. We can come back to the top. Actually, I should just do the scratch first and then say, because I barely started and then I go off on this whole tangent. So let epsilon greater than 0 be given. Choose delta. So what's delta?
Which is the minimum of
The
epsilon over
minimum
5
of
and the square root of epsilon.
epsilon over 5 and the square root of epsilon. Exactly. Okay, and then we'll come over here and just check that it works. I think I'll squeeze that in right over here. Okay, so I'm going to check this delta. So let's assume that absolute x minus 1 is less than delta. Be more careful. Assume that it's not 0 as well. Remember the definition of the limit? X does not equal 1. So now you're checking that for any x that satisfies this assumption that f of x minus 3 is less than epsilon. The absolute value of f of x minus 3 is less than epsilon. Now you can do cases. Now you can say, all right, we're looking at all of these x's. Well, if x is greater than 1, da 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 da, and then if x is less than 1, da 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 da. You have a single delta. You're not like making two problems out of it. This is a single delta for a single problem, right? So now this is fine. If x is greater than 1, you just go straight away to the scratch work that is on the top, right? So it's just 8 minus 5x minus 3 equals 5 times 1 minus x, which is less than 5 times delta. And 5 times delta is definitely less than or equal to epsilon. That's for that case. Right? And then the other case is similar. I won't write it out at this point to save some time. A similar thing. So in both cases you get it. You get the f of x minus L to be less than epsilon. So that's the idea behind that one. Is this making some decent sense? Okay. Do I want to do any more? I feel like I've done a lot. That, should do all of that. Actually, I was worried I wasn't getting enough done. I've done almost everything. I know one more thing I'll write down. I don't think I'm going to do it, but I'll give you this to think about. But then I'm not going to do it because it's actually 4 parts. But this would be something, I did write this down as something for you guys to think about. This would be number 13, but this is going to be on your own. Okay. If f is a function from a to b, and g is a function from b to c, true or false? Of course, I don't do true false that much on exams anymore, but further review is just fine. So the first part is, if g composed with f, which goes from a to c, is 1 to 1, then f is 1 to 1. And that's true or false. B, same assumption about g composed with f. Then is it true that g is 1 to 1? Okay? And for C, we change it to onto here. And then we say f is onto. Is that true or false? And finally, D, we keep all the assumption the same. G is onto. I'll tell you right now that 2 of them are going to be true and 2 of them are going to be false. And it'll be good to practice if you haven't been feeling too good about one-to-one and onto functions to practice these statements. Do you want me to tell you which ones are true or which ones are false, or you want to play with it yourself first? maybe for the sake of the people watching the video,
Yes.
I should put the answers down. I mean, so the first one, I'll just tell you, and then you can try to give examples, or because probably if it was on the test, I would tell you this is true, this is false, prove it, or I would give you the guidance of what to do. So the first one is false. Okay, so F does not. No, I'm sorry. First one is true.
Oh, no.
I'm confusing you now. Yeah, the first one is true. F has to be, if F is not 1-to-1, then the composition won't be 1-to-1. Sorry, so the first one is true. The second one is false. Okay. And then the third one, false. And then the fourth one is true. Okay. There you go. You can have fun reviewing 1-to-1 and on-to. Really, this is Math 280. I don't know if I'd asked this, but it's all right. It's a good thing to review the definitions. So I'm going to let you guys study that one. I probably should get rolling for now anyway. If I think of any more good questions, I'll put them up online. And I will type these up and put them online as well, so you guys will have them to work from. And thanks, guys, for coming.